Tonight, when you turn on the heat, you won't think twice about it. You'll feel the warmth, maybe pull a blanket over your legs, and keep scrolling. But there was a moment in human history when no fire was enough, when the sun itself went away. Not for a night, not for a week, for years. And when it did, the species you belong to almost didn't survive it. This is the story of volcanic winter. And it's also your story. Picture the sky above you going gray. Not the comfortable gray of an overcast afternoon. A deep, sulfurous, suffocating gray that doesn't lift. Morning looks like dusk. Noon looks like evening. The temperature drops. The crops die. The animals disappear. And everyone around you starts asking the same question. Is this the end? Your ancestors lived through that question more than once. The science behind volcanic winter is brutal in its simplicity. When a volcano erupts with enough force, it doesn't just send ash into the surrounding area. It punches sulfur dioxide straight into the stratosphere. That's the upper layer of the atmosphere, between 15 and 50 kilometers above your head. Up there, sulfur dioxide reacts with water vapor and forms tiny reflective droplets called sulfate aerosols. They spread. They circle the planet. And they act like a mirror. Sunlight that was supposed to warm the Earth bounces back into space instead. The planet cools, sometimes by a fraction of a degree, sometimes by several degrees. And several degrees is the difference between a growing season and a famine. Climatologist Michael Rampino at New York University has spent decades mapping the relationship between volcanic eruptions and global cooling events. His research shows that the largest eruptions in human history correspond with periods of starvation, disease, and political collapse across multiple civilizations simultaneously. These weren't local disasters. They were global ones. Now think about the scale of what your ancestors faced. Around 74,000 years ago, a supervolcano on the island of Sumatra erupted. Its name today is Toba. And what it did to this planet was almost incomprehensible. The Toba eruption released somewhere between 2,800 and 3,000 cubic kilometers of material into the atmosphere. For comparison, the 1980 eruption of Mount Street, Helens released about 1 cubic kilometer. Toba was roughly 3,000 times larger. The ash blanketed South Asia, Southeast Asia, and parts of East Africa in layers up to 3 meters thick. The sulfate aerosols it sent into the stratosphere are believed to have caused a volcanic winter lasting 6 to 10 years. Global temperatures may have dropped by 10 to 15 degrees Celsius. The world your ancestors had known simply stopped functioning. Here is where it gets deeply personal. Genetic studies suggest that the human population around the time of the Toba eruption was reduced to somewhere between 3,000 and 10,000 individuals. Some estimates go lower. Think about that. The entire future of your species, every person who has ever lived since then, every language ever spoken, every city ever built, every idea ever written down, may have descended from a group of people small enough to fit inside a single large stadium. Possibly a single small village. This is called a genetic bottleneck. And the Toba catastrophe theory, first proposed by anthropologist Stanley Ambrose in 1998, argues that this near-extinction event is visible in your DNA right now. Humans have unusually low genetic diversity compared to other great apes. Chimpanzees in a single forest in Africa have more genetic variation between individuals than all 7 billion humans on Earth. That sameness in your genes is a fingerprint. It points backward through time to a moment when almost everyone was gone. But they weren't gone. Some of them held on. Paleoanthropologist Michael Petraglia and his colleagues have found stone tools in southern India at sites dating to before and after the Toba eruption. The tools on both sides of the ash layer are remarkably similar in style, which means someone survived there. Someone kept making things, kept thinking, kept teaching. In South Africa, at sites like Pinnacle Point and Blombo's Cave, there is evidence of human communities using ochre, making shell beads, and developing what look like the earliest traces of symbolic thought, all in the period following Toba. The darkness came. And in the places where the ash wasn't so thick, in coastal areas where the ocean kept temperatures more stable, in caves and riverbanks where small groups could find enough food, humans endured. How did they do it? Your body carries some of the answer. When calorie intake drops dramatically, your metabolism slows. Your body starts cannibalizing itself, burning fat stores first, then muscle. Your immune system scales back its non-essential functions to redirect energy toward survival. This isn't a flaw in your biology. It's a feature refined over millions of years. Your ancient ancestors were already built to survive shortage, because shortage was the default condition of life. A volcanic winter wasn't a sudden exception to a comfortable world. It was an extreme version of a hardship they already knew. But biology alone didn't save them. Their minds did. Cognitive flexibility. The ability to switch strategies when the environment changes. To eat something you've never eaten before. To move in a direction you've never traveled. To cooperate with strangers from another group because survival now outweighs competition. Evolutionary psychologist Joseph Henrich at Harvard has argued that what makes humans uniquely capable of surviving environmental catastrophe isn't raw intelligence. It's cultural learning. The ability to transmit knowledge across generations and to adopt new behaviors rapidly when conditions demand it. The survivors of Toba didn't make it because they were stronger or smarter in isolation. They made it because they shared information. They remembered what worked. They passed it down. That same ability is what you are using right now. Toba wasn't the only time it happened. History is punctuated with volcanic winters that reshaped civilizations. In 536 AD, a mysterious atmospheric event, now believed by many researchers to have been a massive volcanic eruption in Iceland or possibly North America, plunged the northern hemisphere into darkness. Medieval historian Procopius wrote that the sun gave out its light without brightness for a full 18 months. Crops failed across Europe, Asia, and the Middle East. Famine followed. Then came the plague of Justinian, one of the earliest recorded pandemics. The historian Kyle Harper at the University of Oklahoma has argued that this sequence, eruption, cooling, famine, plague, set the conditions for the collapse of the late Roman Empire and reshaped the political map of the entire medieval world. Empires that had endured for centuries dissolved in a generation. In 1815, Mount Tambora in Indonesia erupted. It was the largest volcanic eruption in recorded human history. The following year, 1816, became known as the Year Without a Summer. Snow fell in New England in June. Crop failures swept through North America and Europe. In India, the disrupted monsoon led to drought. In China, cold and floods destroyed harvests. An estimated 200,000 people died directly. Millions more starved in the years that followed. In Europe, starving rural populations flooded into cities already strained by the aftermath of the Napoleonic Wars. The social upheaval contributed to waves of emigration that permanently altered the demographic shape of the Western world. And yet, humans adapted, again. The same year without summer that killed harvests across the world also gave birth to new ideas. Mary Shelley, trapped inside by endless rain on the shores of Lake Geneva, wrote Frankenstein, a novel about what happens when human ambition overreaches nature's limits. The first gasoline-powered bicycle was invented partly because oats, the fuel of horses, had become catastrophically expensive after the harvest failures. Necessity reached in and pulled ingenuity out of people who had no other choice. Here is what that tells you about yourself. You are not descended from the people who gave up. You are not the inheritor of the people who waited for the sun to come back and did nothing while they waited. The genetic line that reaches from Toba through every volcanic winter in recorded history to the moment you are sitting in right now passes through the ones who moved, who found the coast, who learned to eat shellfish and seaweed and things that nothing in their experience had told them were food, who stayed close enough to other humans to share warmth and knowledge even when resources said they should compete, who kept teaching their children skills that felt pointless in the immediate crisis, but that would matter desperately 6 months later when conditions shifted again. Resilience is not a modern self-help concept. It is a 60,000-year-old inheritance that you carry in your cells and in your culture simultaneously. But to really understand what volcanic winter did to your species, you have to go deeper than the genetics. You have to understand what it felt like, not in the abstract, not in the data, in the body. In the mind. In the small, specific, human moments that don't leave fossils, but that were just as real as the ash layers scientists can measure today. Imagine you are one of those survivors. Not a scientist's abstraction. A person. You have a name, though no one outside your small group will ever know it. You have children, or maybe you are a child. You have a fire, but the wood is running out. The animals that used to come to the waterhole haven't come in weeks. The plants that used to grow along the riverbank are gone, smothered under a film of gray ash that coats everything like a second skin on the world. You don't know what a volcano is. You don't know that a mountain on the other side of an ocean you've never seen just changed the chemistry of the sky above you. All you know is that something is wrong. Something enormous and invisible is pressing down on everything, and the cold that came with it is like nothing any elder in your group has ever described. What do? If you are like the ancestors who survived, you watch. You pay attention. You notice that some plants are still growing in the cracks along certain south-facing cliffs where a little residual warmth holds on. You notice that certain insects are still active in places where underground water keeps the soil slightly warmer. You notice that the shellfish on the coast don't care about ash in the sky because they live in the ocean, which changes temperature far more slowly than air. And you move toward those things. Slowly. Carefully. With everyone you trust. Evolutionary biologist Richard Wrangham at Harvard has spent years studying the relationship between cooked food and human brain development. His work shows that cooking dramatically increases the caloric return from food, effectively allowing a smaller volume of food to sustain a larger brain. For Toba survivors, this matters enormously. Groups that had already figured out how to consistently control fire and cook their food could extract more energy from less. They could survive on resources that would have been insufficient for groups still eating entirely raw. Fire, in this context, was not just warmth. It was a caloric multiplier. It was the technology that gave some groups a survival margin wide enough to endure years of reduced food availability. And the groups that made it through weren't just lucky. They were, in a very real sense, more culturally sophisticated than the ones that didn't. Think about what cultural sophistication means in this context. It doesn't mean art galleries and philosophy. It means knowing things. Knowing which roots can be boiled to remove their toxins. Knowing how to read water below the surface of dry ground. Knowing how to construct a shelter that redirects wind rather than fighting it. Knowing the migration routes of animals well enough to predict where they might still be found, even when they've been displaced by the cold. Every piece of knowledge like that was hard-won. Someone before you died learning it or failed to survive without it, and the lesson got passed forward. In a volcanic winter, the depth of a group's collective knowledge library was the difference between extinction and continuation. This is also why language matters so much in this story. Language, true grammatical language that allows complex knowledge to be transmitted with precision, is believed by many researchers to have emerged or dramatically accelerated in exactly this period of human prehistory. Linguist and cognitive scientist Daniel Everett has argued that language didn't just allow humans to communicate emotions or simple commands. It allowed them to represent imaginary scenarios, to say not just this is what happened, but this is what could happen if, to plan for futures that haven't arrived yet, to describe dangers that aren't immediately visible, to name the lessons of the dead so the living can use them. In a volcanic winter, a group with sophisticated language could share survival strategies across time in ways that groups without it simply couldn't. The story of how your great-great-grandmother found water in the dry season could be passed down and used by someone who had never met her and lived in a time she couldn't have imagined. That is what you are doing right now. You are receiving a story about people who are long dead, and the story might matter to how you understand your own life. That unbroken chain of transmitted knowledge is not a small thing. It is the deepest and most defining thing about your species. Now let's look at what volcanic winter did to the groups that survived Toba in more detail. Because the story after the eruption is almost as dramatic as the eruption itself. Archaeologists studying the period between 70,000 and 60,000 years ago have found something remarkable, an explosion in the variety and sophistication of human tool technologies. Bone tools. Composite tools, meaning tools made of multiple materials assembled together. Pressure flaking techniques that produce sharper, more precisely shaped stone edges. Decorative objects. Pigments used systematically rather than occasionally. The full behavioral package that anthropologists sometimes call behavioral modernity seems to emerge or intensify in the period after Toba. Not before it, after it. Why would a near-extinction event lead to an explosion of innovation? One answer is population dynamics. When a population is under extreme stress and reduced to small, isolated groups, something called founder effects can create rapid divergence. Small groups, separated from each other by hostile landscapes of ash and cold, begin solving the same problems in different ways. Each group invents its own variations on tools, on food processing, on social organization. And then, when conditions eventually improve and groups begin making contact again, they trade not just food and mates, but ideas. The creative explosion you see in the archaeological record after Toba may be the direct result of 1,000 small innovations recombining when the survivors finally found each other again. This is a counterintuitive truth about catastrophe. It doesn't just destroy. Sometimes it diversifies. Sometimes it forces the kind of creative pressure that comfortable stability never would. But before things got better, They got worse. Much worse. And the details of that descent matter if you want to understand what your ancestors were truly made of. In the years immediately following the Toba eruption, the feedback loops were merciless. Cooler temperatures meant less evaporation from the ocean's surface. Less evaporation meant less rainfall. Less rainfall meant more drought. More drought meant less vegetation. Less vegetation meant more bare soil. More bare soil meant more reflectivity, which meant more of the sun's energy bounced back into space, which meant the planet cooled even further. Scientists call this a positive feedback loop, though there is nothing positive about it from a survival perspective. It means that one disaster triggers a cascade of smaller disasters, each one making the next more likely. The world didn't just get cold, it got drier, it got more barren, it got harder in every direction simultaneously. And yet your ancestors were not the only creatures being tested. The megafauna of Africa, Asia, and Eurasia were also under enormous pressure during and after Toba. Woolly mammoths, cave bears, giant ground sloths, and a dozen other enormous species that had thrived for hundreds of thousands of years were in decline. The specific timing varies by species and region, but the broader pattern is real. The period around and following Toba corresponds with stress signals in the fossil records of large animals across multiple continents. For a species of human that was already hunting these animals, the disappearance of large prey created yet another layer of crisis on top of a crisis. The forests were gone. The rain was gone. And now the biggest, most calorie-dense food sources were disappearing too. How do you eat when there is nothing left to eat? You get creative. And the archaeological evidence says that's exactly what happened. Sites dating to the post-Toba period show evidence of intensified shellfish consumption, processing of otherwise unpalatable plant foods, and systematic exploitation of insects. Entomologist Marcel Dick at Wageningen University has documented just how nutritionally dense insects are as a food source. High in protein, high in fat, available in large quantities, even when other food sources have collapsed. The ancestors who survived Toba were almost certainly eating insects. Not because it was a delicacy, because it kept them alive. And the flexibility to look at something small and crawling and see food rather than revulsion is itself a survival skill. Your brain still has the reflex of disgust toward insects. That reflex is a luxury your Toba-era ancestors could not afford. Now step forward in time, out of the prehistoric darkness and into the first civilizations. Because the story of volcanic winter doesn't end with Toba. It keeps happening. And when it happens to civilizations rather than nomadic bands of hunter-gatherers, the effects are even more visible and even more dramatic. Consider what happened in Egypt around 2200 BC. The Old Kingdom, the civilization that built the Great Pyramids at Giza, one of the most sophisticated and centralized states the ancient world had ever seen, collapsed. Completely. The central government fragmented. The bureaucratic networks that had held Egypt together for 600 years dissolved. Regional warlords fought for control of diminishing resources. Scholars studying this period have debated its causes for over a century. But one cause that has gained significant traction in recent years is climate disruption linked to a series of volcanic eruptions in the late 3rd millennium BC. Paleoclimatologist Harvey Weiss at Yale University has documented a severe and abrupt drought that struck the ancient Near East around 2200 BC. His research, which draws on evidence from soil samples, pollen records, lake sediment cores, and archaeological sites from Syria to the Nile, points to a catastrophic agricultural collapse triggered by a sudden shift in climate. Egypt's famine inscriptions from this period are among the most haunting texts in ancient history. One provincial governor named Ankhtifi describes a country in which everyone was dying of hunger, in which people were eating their own children. Whether or not the volcanic forcing of climate was the primary driver, the pattern is consistent. Volcanic disruption of rainfall and temperature, agricultural failure, state collapse, and Egypt was not alone. The Akkadian Empire, the world's first true empire stretching across Mesopotamia from what is now Iraq into Syria and Turkey, collapsed almost simultaneously. The Indus Valley civilization, centered in what is now Pakistan, entered a period of decline around the same time. Cities were abandoned. Trade networks that had connected civilizations across thousands of kilometers went quiet. The late 3rd millennium BC looks, from the archaeological record, like a global civilization crash. Not triggered by war. Not triggered by internal political failure. Triggered, at least in part, by the climate. By the sky. What survived that crash? Ideas. Language. The accumulated knowledge stored in the heads of ordinary people who had never lived in a palace and whose names were never written down. The farmers who adapted their crops, the herders who moved their animals, the craftspeople who kept their skills alive in smaller communities when the cities emptied. Civilization contracted, but it didn't die. It compressed into the people. And when the climate stabilized again, those people rebuilt. Every civilization you know about today is a descendant of one of those compressions. Now move forward to an eruption that sits on the very edge of recorded history. In 426 BC, the Greek historian Thucydides recorded something strange happening to the island of Melos. Strange lights in the sky, earthquakes, the sea pulling back from the shore before rushing back in a great wave. Modern volcanologists believe this corresponds to a major eruption of Santorini, known in antiquity as Thera, the same volcano whose catastrophic Bronze Age eruption around 1600 BC is now believed by many researchers to have contributed to the collapse of Minoan civilization. Santorini sits in the Aegean Sea like a broken ring, the flooded crater of what was once a massive volcanic island before it destroyed itself. The Bronze Age Thera eruption is particularly significant because it may be the origin of one of history's most persistent myths. The philosopher Plato, writing around 360 BC, described a great island civilization beyond the Pillars of Hercules that was swallowed by the sea in a single day and night. He called it Atlantis. Most historians treat this as an allegory or a literary invention. But a significant minority of researchers have suggested that the story preserves, in distorted form, a cultural memory of the Thera eruption and its aftermath. A sophisticated Bronze Age civilization suddenly overwhelmed by catastrophe, its cities buried under ash, and its coastlines reshaped by tsunamis. Memory stretched across 1,000 years of retelling until it became myth. Until it became legend. Until Plato wrote it down and it became immortal. Your ancestors told stories about the sky falling. And sometimes the sky actually had. This is one of the stranger aspects of living in the aftermath of volcanic catastrophe. The event is so overwhelming, so far outside the normal frame of human experience, that ordinary people reach for the only containers large enough to hold it: myth, religion, story. Around the world, in cultures with no contact with each other, you find flood myths, fire myths, darkness myths, sky gods who punish humanity with years of cold and famine. Some researchers argue that these myths are not merely metaphorical. They are memories, encoded in story, because story was the only technology ancient people had for long-term information storage. Volcanologist Clive Oppenheimer at Cambridge University has spent years tracing the relationship between major volcanic events and mythological traditions. His research suggests that oral cultures living near active volcanic regions developed remarkably accurate, descriptive traditions about eruption behavior, passed down through generations as stories about angry mountains, sleeping giants, and fire-breathing gods. In some cases, indigenous oral traditions have been shown to accurately describe volcanic events that occurred thousands of years before contact with written civilization. The stories were not decoration. They were data. Your storytelling instinct is a survival technology. Now consider one more volcanic winter that most people have never heard of, but that may have permanently altered the course of world history. In 1257 AD, an enormous eruption occurred somewhere in the tropics. For decades, scientists couldn't identify its source. Ice cores from both the Arctic and Antarctic showed a massive sulfur spike from that year, indicating a tropical eruption large enough to deposit evidence at both poles simultaneously. Tree rings from Europe, Asia, and the Americas all showed abrupt growth suppression for several years following 1257. The year 1258 saw record cold, crop failure, and famine reports from England to Japan. The source volcano was only identified in 2013 by a team led by geologist Frank Levine. It was Samalas, on the island of Lombok in Indonesia, directly adjacent to the island that would later produce Tambora. Samalas ejected an estimated 40 cubic kilometers of material, making it the largest eruption of the past 7,000 years. Its cooling effect on the northern hemisphere in the years following 1257 directly contributed to the Great Famine of the early 14th century, which itself weakened the immune systems and social structures of European populations, making them more vulnerable to the Black Death when it arrived in 1347. The chain of causation connecting a volcanic eruption in Indonesia in 1257 to the deadliest pandemic in European history, almost a century later, is not direct. But it is real, and tracing it reveals just how profoundly a single geological event can cascade through human history across generations. Now think about what scientists know about the future. Volcanologist and hazard researcher Christopher Kilburn at University College London studies what he calls the precursors to supervolcanic eruptions, the early warning signs, the ground deformation, the changes in gas emissions, the micro-earthquakes that cluster along fracture lines deep in the earth. His work, along with the work of dozens of other researchers monitoring sites like Yellowstone in Wyoming, Campi Flegrei in Italy, and Taupo in New Zealand, paints a clear picture. The Earth's volcanic systems are not dormant. They are breathing, slowly, on timescales that dwarf human civilization. But they are active. And the question of when, rather than whether the next major volcanic winter will occur, is one that planetary scientists take seriously. Yellowstone last erupted in a supervolcanic event approximately 640,000 years ago. Its current activity levels, measured in ground uplift, hydrothermal output, and seismic patterns, are being monitored continuously. The United States Geological Survey maintains a 24-hour watch on Yellowstone's caldera. Not because an eruption is imminent, but because in geological time, 640,000 years is not that long ago. And when the next major eruption comes, wherever it comes from, the global climate consequences will not respect national borders or political systems, or the particular moment in technological development that humanity happens to have reached. This is not meant to frighten you. It is meant to contextualize you. Because the other side of this truth is that your species has survived every volcanic winter the Earth has thrown at it so far. Not easily. Not without devastating loss. Not without periods that came terrifyingly close to the end. But you are here, reading this, thinking about it, which means the chain held. And the chain held because of specific, identifiable human behaviors. Flexibility over rigidity. Cooperation over isolation. Cultural transmission over individual knowledge. Creativity under pressure. The willingness to abandon what isn't working and try something that has never been tried before. These are not abstract virtues. They are survival technologies that were field-tested in conditions that would make anything you have ever called a hard day look like a minor inconvenience. They were proven effective in years of darkness, in skies that didn't clear, in seasons that didn't turn, in a world where the rules had changed and nobody knew what the new rules were yet. Your ancestors figured it out anyway. There's one more piece of this story that rarely gets told, and it might be the most important one. Surviving a volcanic winter was not just about endurance. It was about community. The scientific evidence is unambiguous on this point. Small, isolated groups did not survive Toba. The groups that made it were the ones that maintained social cohesion under pressure, the ones that kept sharing. That kept making decisions together. That found ways to manage internal conflict when resources were scarce enough to make conflict feel justified. Anthropologist Kim Sterlny at Australian National University has argued that the evolution of modern human cognition is inseparable from the evolution of modern human sociality. You cannot think like a human without being embedded in human relationships. The big brain that allows language and planning and abstract thought evolved in a context of deep interdependence. It is a social organ. It was built for and by groups of people who needed each other to survive. In a volcanic winter, that interdependence was exposed with brutal clarity. The person next to you was not a competitor for resources. They were part of your immune system, part of your memory, part of your food-finding network, part of your emotional regulation system. Separate from them, you were smaller and more fragile than you seemed. Together, you were something the cold and the dark had not yet figured out how to kill. That is still true, right now. Today. The volcanic winters of the past didn't only test human endurance, they refined it. Every time the sky went dark and the temperature dropped and the food ran out, the people who survived left behind a slightly more capable lineage. Not because suffering improves people in some poetic sense, but because survival selects. The behavioral traits that pulled people through a volcanic winter, flexibility, cooperation, innovation, cultural memory, are the same traits that define what it means to be human now. You live in a world of electric lights and climate-controlled rooms and global food supply chains so complex that a single harvest failure in one country barely registers as an inconvenience in another. That insulation from catastrophe is astonishing. It is the accumulated work of every generation that survived, every disaster that came before this one. It is not permanent. No insulation ever is. But it is real. And it was built by people who knew, somewhere in their bones, even if not in their words, that the sky could go dark again. Tonight, when you turn on the heat, that warmth is not just physics. It is the latest answer in a question your species has been answering for 74,000 years. How do we survive when the world stops working the way it's supposed to? Your ancestors answered it with fire, with migration, with memory, with each other. You inherited their answer. You are their answer. The sun went away, and your family refused to go with it.